This is going to be a video where I work out the problems that are on the review sheet that I provided for test number 2 in Math 1111 College Algebra. So I'm just going to jump right in. I copied them directly out of GoView and we'll work through the problems. So this covers lessons 5, 6, 7, and 8 in the content of Math 1111. So we begin with the first question that says, find the y-intercept of the line y equals x minus 6. And so write your answer as an ordered pair. So we're looking for the y-intercept. The y-intercept is where the graph of the line would cross the y-axis. And so you're ultimately trying to solve for y. So we have to let the x value be 0. So if I let x be 0 and I substitute it into the equation that I'm given, y equals x minus 6, and I'm going to let x equal 0. So I have y equals 0 minus 6. So y is negative 6. So written as an ordered pair, the y-intercept is 0, comma, negative 6. It's a straight, flat out plug and chug. Question number 2 asks you to find the x-intercept of the same line, y equals x minus 6. The x-intercept is where the graph of the line would cross the x-axis, and so you want to solve for x. It's the x-intercept crosses the x-axis and you solve for x. So we're going to let y equals 0, and again we need to solve for x. So again we have the equation y equals x minus 6. So I have 0 equals x minus 6. I'm going to add 6 to each side in order to isolate the x. So I have 6 equals x. So written as an ordered pair, the x-intercept is 6, comma, 0. Again, it's pretty much a flat out plug and chug. The next question says find the slope of the line through the points. So you will need to know or be familiar with the slope formula. You do get to use your notes on the test, so maybe make yourself a formula sheet and include the slope formula. Slope is y2 minus y1 divided by x2 minus x1. A lot of students view it as rise over run. So again, you have the formula, you have the 2 points given to you, and it becomes a substitution problem. I like to label my points so I don't get confused. So I have x1, y1, that's the first point I'm given, and then I have x2, y2, which is the second point I'm given. So then I begin to do the substitution. Be careful and watch the signs. I have negative 6 minus negative 1 divided by 0 minus 7. Okay, be careful. That becomes negative 6. Negative and a negative become a plus over 0 minus 7 is negative 7. Negative 6 plus 1 is negative 5 over negative 7. That's really a division. You have a negative divided by a negative. So ultimately, your answer is the slope is positive 5/7. Negative divided by negative makes a positive. Question number 4 says find the equation of the line through the points. Put your final answer in slope-intercept form. So slope-intercept form is y equals mx plus b, where m is your slope and b is the y-intercept. But to get to slope-intercept form and to write the equation of the line, we initially should use what's called the point slope form or point slope formula. Again, this might be something you want to write down. The way I write it is y equals m times x minus x1 plus y1. M here is your slope and x1, y1 is a point on the line. Now, one of the challenges you have in this particular problem is that you are given 2 points. It doesn't give me the slope, but with 2 points, I can calculate the slope of the line. So I have to first find the slope of the line. The slope formula, remember, is y2 minus y1 over x2 minus x1. Again, I tend to label my points so that I don't get confused. So I have x1, y1, x2, y2. It doesn't really matter which one I make point 1 and which one I make point 2. I just tend to work left to right. So then I'm going to plug and chug. So I have 6 minus a negative 2 over 1 minus 9. So I have 6 plus 2. Remember, minus and minus make a plus. 1 minus 9 is negative 8. So I have positive 8 over negative 8, which would simplify to negative 1. So the slope that I'm going to use to calculate this line is negative 1. So I'm going to use the slope value of negative 1 and one of the points. It doesn't matter which one. I'm going to use this one since it's already labeled x1, y1. And I'm going to plug into the point slope form. So that I have y equals negative 1 times x minus 9 plus the negative 2. Now that is the equation of the line in point slope form, but remember we're trying to get to the slope intercept form, so I have to do the distributing. So I'm going to do y equals negative 1 times x is negative 1x. Negative 1 times negative 9 is positive 9, plus negative 2 is the same as minus 2. And then I'm going to simplify. Y equals negative 1x. We don't normally write the 1, plus 7. This would be the equation of the line in slope-intercept form, but it's a process. You have to find the slope first using the 2 points that you're given, then substitute into the point slope formula, and then simplify it to get to slope-intercept form. Question 5 asks you to find the equation of the line that goes through the point -1, 7, which is parallel to the line y equals 8x plus 4. And again, ultimately, you want your answer in slope-intercept form. So again, in order to write the equation of a line, any line, you have to be given the slope and a point. Okay, so to write the equation of a line, you need a point and the slope so that you can use the point slope form or point slope formula. Well, I'm given a point. That's going to be my x1, y1, but I need my slope. And more specifically, in this problem, I need the parallel slope, and it has to be parallel to y equals 8x plus 4. Well, what you have to remember in this scenario is that parallel lines have the same slope. So I'm given the equation of a line. This is a line. It's in slope, intercept form of a line. And I know that the number in front of the x represents the slope. That's m. And the constant is the b, or my y-intercept. So the slope of the given line, okay, the slope of the given line is 8. So that means the slope of the parallel line is also going to be 8 because they have to be the same. So I'm going to use the point that I was given initially, which is -1, 7, and my parallel slope, and I'm going to substitute into point slope. Y equals m times x minus x1 plus y1. And I'm going to do the substitution. So I have y equals 8 times x minus a -1 plus 7. Okay, so that gives me 8 minus a minus makes a plus, so x plus 1 plus 7. Then I need to put it in slope-intercept form. So to get it to slope-intercept form, I need to distribute and simplify. So I have y equals 8 times x is 8x. 8 times +1 is +8 plus 7. So I have y equals 8x plus 15. So my answer, the equation of the line parallel to 8x, y equals 8x plus 4 and passes through -1, 7 is y equals 8x plus 15. Question 6 is a similar question, but question 6 wants us to find the equation of the line that passes through the point -4, 5, which is perpendicular to y equals 1/4 x minus 1. And again, our final answer goes in slope-intercept form. Here again, to write the equation of the line, we begin with the point slope formula, but to write the equation, we need a point and the slope. We're given a point. We are given -4, 5. So that will be, in terms of my formula, that will be my x1 y1. And again, I need the slope, but specifically I need the slope that is perpendicular. For perpendicular lines, the slopes of perpendicular lines are negative reciprocals of each other. So in this scenario, again, looking at the equation that we're given to start with, y equals 1/4 x minus 1, I know that the 1/4, the number in front of the x, is my slope, which is m, and the minus 1 is the y-intercept, which is b. So the slope of the given line is 1/4. The slope of the perpendicular line is going to be the negative reciprocal. Okay, the idea of a reciprocal means you're going to flip it over. Okay, so I'm going to flip that value over. So it's going to become 4/1, and then the negative means I'm going to change the sign. So it was originally positive. I'm going to make it negative. So ultimately, the perpendicular slope is -4. And that's the value that I need to use in the point slope formula to find the equation of the line. So substituting into the point slope form, y equals m times x minus x1 plus y1, I would have y equals -4, my perpendicular slope, times x minus the -4 plus 5. So I have y equals -4 times x plus 4, negative and a negative make a positive, plus 5. But I'm not in slope intercept form. I need to distribute and combine like terms. So I would have y equals -4 times x is -4x. -4 times 4 is -16 plus 5. Combining like terms, I have y equals -4x minus 11. And that would be the equation of the line that is perpendicular to the given one and passes through the point -4, 5. All right, moving on to question 7. Question 7 asks you to solve the system of equations. It's a system because I have two variables and two equations. And I ultimately want to know what values or what is the value for x and what is the value for y that makes both of those equations true. There's several techniques that you learned for solving a system of equations. You can use graphing, you can use the substitution method, or you can use the elimination or the addition method. The way this problem is set up, I think I'm going to do the elimination, or some folks call it the addition method. Okay, so to do that, I need to have the same number in front of the x or in front of the y's, and they have to be opposite. So I want opposite but the same number. So I think it'll be easier maybe if I eliminate the y's. So I'm going to multiply the top equation by 4, and I'm going to make it negative so that I can have a positive 4 there. Okay. So if I do that multiplication, distributing it out, I have negative 20x plus 4y equals, let's see, negative 18 times negative 4, using my calculator, is positive 72. And then I'm going to bring the other equation over, 3x minus 4y equals 13. And then I'm going to add those two equations together. So I would have negative 20x plus 3x is negative 17x. Plus 4y minus 4y is 0. The y value is eliminated, equals 85. So then I have a basic equation with one variable. I'm going to divide both sides by negative 17. So x equals 85 divided by negative 17 is equal to negative 5. So I know that my x value is negative 5. I'm then going to take that value for x and substitute it into one of the given equations. It doesn't matter which one. Okay, you can choose whichever one you maybe like better. So I'm going to substitute negative 5 into the bottom equation. So I would have 3 times negative 5 minus 4y equals 13. So I have negative 15 minus 4y equals positive 13. My goal here is to get the y by itself. So I need to add 15 to either side. So I have negative 4y equals 28. Then I'm going to divide both sides by negative 4. So y equals negative 7. So the solution to my system, or the ordered pair that makes both equations true at the same time, would be negative 5, negative 7, written as an ordered pair in the order x, comma, y. The next question says, solve the systems, write the answer as an ordered pair. When I look at this particular problem, I noticed that the first equation is already solved for x. So I'm going to use the substitution method to solve this one, since the top equation is already solved for x. So I would take the first equation and substitute it into the bottom equation, so that I have 5 times negative y minus 9 minus 6y equals negative 1. Then I'm going to distribute and collect like terms. So I have 5 times negative y is negative 5y. 5 times minus 9 is minus 45, minus 6y equals negative 1. Combining like terms, negative 5y minus 6y is negative 11y, minus 45 equals minus 1. I need to isolate the y, so I'm going to add 45 to either side to isolate the y. So I have negative 11y equals negative 1 plus 44, plus 45 is 44. Then I'm going to divide both sides by -11. So y equals -4. So my y value is -4. I'm then going to take that value that we just found and substitute it back into the first equation so that I would have x equals the negative of -4 minus 9. Well, minus a minus makes it a positive, so I have x equals 4 minus 9, so x is -5. Now guys, if you're not good with doing subtraction of positive and negative numbers, please use the calculator. But my ultimate answer here in order pair form would be -5, -4. The next question says determine if -9x minus 3y squared equals 6 is a function. Well, there's several ways to do that. If we wanted to look at the graph of this equation, we would have to first solve for y. So if you want to look at the graph, you got to solve for y. So if I take this equation, -9x minus 3y squared equals 6, and I try to solve it for y, I'm going to add 9x to either side. So that I have -3y squared equals 6 plus 9x. Then I'm going to divide everything by -3. So I have y squared equals 6 divided by -3 is -2. 9 divided by -3 is -3x. And then I have to get rid of the square. So I would square root, let me get a different color. I would take the square root of both sides, remembering it could be positive or negative. So y equals positive or negative square root of -2 minus 3x. And then I can graph that or those two equations. I would have to graph y equals the positive square root of -2 minus 3x and graph the opposite or the negative square root of -2 minus 3x at the same time. You have to graph both pieces. You have a positive and a negative. So if I create that graph, you get what appears to be a sideways looking parabola. So if I run the vertical line test on that graph, it's going to fail the vertical line test, because if I try to draw a vertical line through that graph, it's going to cross 2 times. So this particular equation would not be a function. Another clue that it's not a function is the fact that I have this plus or minus, and I end up with 2 different equations, which means I'm going to get 2 different outputs. And remember, to be a function, it's 1 input to 1 output. There's no repetition in the y values. So the answer here would be no, this is not a function. Question 10 is a multiple choice question, so it's actually a multiple select question. because it says select all the correct answers. So there could be more than one correct answer here. You're trying to decide which one or ones of these tables could be functions. Well, basically, remember, to be a function, there can be no repetition. There's no repeat in the y values. So I'm going to focus my attention on the y values. If I look at this first option for the y's, or the output, I have 6, 7, -2, and 11. There's no repeat, so I'm good. That one could be a function. For the second one, I have -1, 3, 13, and -2. Again, I have no repeat. So that one could be a function. In the third option, notice you have -1, 12, 9, and 12. You have a repeat. So that's not a function. In the fourth option, you have 9, 7, 9, and 3. Again, you have a repeat, not a function. Last one, you have 3, 10, 7, and 0. So that one could be a function. So there are 3 that could be functions. Again, you want to look to see, to be a function, there can be no repeat in the y values. It is okay if it repeats in the x. Question 11 is also multiple select, and you're asked to determine which graphs represent a function. Graphically, we can use the vertical line test. So if I can draw a vertical line through the graph and it only crosses one time at any given point, then I'm good to go. If it crosses more than once, that's bad. So in this case, notice I cross 1, 2 times at that particular point. That means that that particular graph is not a function. I wanted to write it big so you would see it. The second one, it kind of looks like it's a little curvy, and if you draw the line in just the right place, you're going to cross 2 times. So again, because I crossed 2 times, this second option is not a function. The third one, even if I draw, depending on, where I draw it, no matter where I draw it, I only cross one time at any given point. Because I only cross one time at any given point, this one is a function. Fourth one, again, you kind of have this arc looking shape. If you draw a vertical line at various places in this arc looking shape, you only cross one time. So this fourth option is also a function. Make sure I didn't miss one. Number 12, we get into functions, and it tells us that the function g is defined as g of x equals -4x minus 3, and define g at -1. Well, guys, all they're asking you to do, this -1 here is your x, that's your input. So they're basically wanting you to plug and chug, to plug the number into the function and find the answer. Okay, don't overthink it. It is that straightforward. So I would have g at -1 equals -4 times -1 minus 3. Do the math. -4 times -1 is +4 minus 3, and +4 minus 3 is 1. So G at -1 is 1. So the answer I would look for, assuming this one is multiple choice, or I would enter the value of 1. Again, if you struggle with positive and negative numbers, you can use a calculator. And please do. Don't miss it because you're too scared or too vain, if you will, to use the calculator. 13 is the same type question. They want you to find F at -1. It's a plug and chug. It's a little bit more involved type equation. So we have -3 times -1 squared minus 2 times -1 plus 1. Now again, I can type this entire thing into my graphing calculator and it will do it all at one time. In case you're going to use the calculator, I want to make sure you know how to enter it correctly. So I'm going over to my calculator. I would type -3 times, and I need to put parentheses around the -1 so that the computer or the calculator knows the negative goes with the 1, square it, minus 2 times, I'm just going ahead and put parentheses around my -1 again, minus 1. I think that was the equation. Let me make sure I plugged it in right. -3 times -1 squared minus 2. Oh, it's plus 1. Sorry. A plus. And then I hit enter. And it gives me a value of 0. Okay, so it will do it in your calculator, but let me walk it through by hand. Okay, so if I'm following order of operations, I would do exponents first. So -3 times +1. -2 times -1 is +2 plus 1. Then I'm going to come back and do the multiplication. -3 times 1 is -3 plus 2 plus 1. -3 plus 2 is -1 plus 1 does give me the value of 0. Whether you do it by hand or you use the calculator, it's 0. Again, if you struggle with positive and negative numbers, please use the calculator. Question 14 says to find the domain of the function represented by the ordered pairs. Okay, the domain is your x values. What values are used or could be used for the x, which is the horizontal axis. The range corresponds to the y values. In this case, you're given a list of ordered pairs. So the domain is the list of the x values. Now, usually the domain is written from low to high. So the smallest of those values would be -7, -5, -2, and 6. They don't have to be written, and usually they're not, in the order that they're given. The values are usually ordered from low to high. But the domain, because this asks for domain is your x. Question 15 is a similar question. It's asking you to find the domain, which are going to be the x values, but instead of an list of ordered pairs, you have a graph. And it's important that you pay attention to the graph. This little open circle dot means that that value is not used, but it also means that it stops at that point. The colored in dot at the other end means that that value is used, but again, it stops at that point. Typically, if we want things to continue on, it'll have an arrow on the end, or sometimes it just seems to keep going or runs off the graph. Okay, if they want it to stop, usually you're going to see a dot. Now, the easiest thing to do here in reading this graph, the first thing I want to do is identify kind of that beginning point and ending point. If I look at this point is -6, +1, and this value is 1, -5. Okay, for the x values, for the domain, you're going to look at the x-axis and think about what numbers you could use for x. You always, again, read from left to right. So if I think about kind of walking along the x-axis, the first place that I'm going to actually see this graph is when I get to this point of -6. The x value is -6. But that is that open dot, which means it's not used. So we indicate that the open dot is indicated by a parenthesis. And I keep going. I'm still going to see it at -5. I'm still going to see it at -4, -3, -2, -1, 0, 1. But when I get to 2, I don't see anything. So the last place I see something is at +1, but +1 is part of the graph. It's included because it's a colored in dot, so I would have a bracket. So my domain runs from -6 to +1, but I do not include the -6 as indicated by the parenthesis, but I do include the +1 indicated by the bracket. Question 16 is the same graph, but this time they ask you to find the range. The range is the y values. The same information that I just gave you still applies. If you have this open dot, that means that that value is not used, and again the graph stops. On the other end, that value, because the dot is colored in, is used, but again it stops. And again, I would begin by identifying my ordered pairs. Again, this ordered pair was -6, +1, and this one is 1, -5. This time for the range, I'm going to focus on the y-axis, and we work bottom to top. Again, think about it, you're going from low to high, bottom to top. And so if I'm kind of maybe riding the elevator here, okay, I'm not going to see anything on my y-axis until I get to the value of -5. So I begin seeing something at -5. It is a colored in dot, so it's used, so it gets a bracket. I'm still going to see something at -4, -3, -2, -1, 0, and 1. But when I get to 2, I don't see anything. So I have to stop at 1, but at 1 it's an open dot, so it's not included. Guys, the parentheses and the brackets are important. The bracket, the square piece, squared off piece is a bracket. It means the value is used or included. Parenthesis means the value is not used or not included. And it matters. So be extra, extra careful. Okay, then question 17 asks you to determine where this function is decreasing. Okay, decreasing means where does it appear to go down as you move left to right. In terms of deciding where a graph moves or decreases or increases, it says determine the interval. The interval is always stated in terms of the x values. Again, we always read a graph left to right. So if I start thinking about this graph, and let's maybe use, okay, so I'm moving along, and it looks like I'm going up, okay, which would be increasing. And when I get to this point right here at the top of the hill, then it appears that visually I'm going to go down until I hit the bottom. And then it appears that I start to go up again. Notice how this graph doesn't have any, it doesn't have arrows on the end, but it also doesn't have the dots. So that implies to me that this graph would keep going forever and ever in both directions. So I have 2 points of interest. This first point at the top of the hill is at 0, 4. The one at the bottom here is 2, 0. So I go down, I am decreasing between the x values of 0 and 2. And guys, we always use parentheses when we're thinking about increasing and decreasing. You'll never see brackets there. It's always parentheses. So I'm going down between 0 and 2. Just as a side note, this value that's at the top of the hill, we would call the relative maximum. It's not part of the question. The one here at the bottom of the hill we call the relative minimum. Max means it's the highest. Minimum means it's the lowest, and it's relative to the values around it. I believe question 18 uses the same function, but again, this one now asks us for where is the function increasing. Okay, where is the function increasing? Increasing means that it goes up as you move left to right. You always read a graph left to right. Again, the intervals that we're going to create, whether you're doing increasing or decreasing, are going to be in terms of the x. So again, if we look at this graph, I start out and it does look like I'm going up until I get to this point. And then it appeared that I was going down till we get to here. And then it appears that we go up again. So the two places that I'm going up is where I'm increasing. So I have two areas or two intervals where I'm increasing. The other thing that you need to realize is, again, because there's not a dot, we have to assume this graph keeps going on and on and on and on and on and on to forever. So that would be to negative infinity. Same thing here at the top. It keeps going up and up and up and up and up and up to positive infinity. Now, I don't see that visually. Again, I'm having to make that assumption. Okay, so let's see what we can do. The two key points here that we're looking for, the top point is at 4, 0. The bottom one is at, oops, I wrote that wrong. Sorry, my fault. This should be 0, 4. I got it backwards. Sorry. Okay, so we start out, and again, under the assumption it's going to go forever, we start at negative infinity, and we increase or go up until we get to an x value of 0. The or, when you have more than one, we join it by this little symbol. It looks like a funky looking U. Or when I hit a value of 2, and then I keep going to positive infinity. Okay, the last, I actually know because I looked ahead. The last two questions deal with average rate of change. Okay, the last two questions deal with average rate of change, which is a similar concept to slope, but it's related to curves as opposed to lines. So this is like the slope of a curve. And it's a formula. Now the formula looks wonky, okay? But it basically is, if you think about the slope, is y2 minus y1 over x2 minus x1. The formula for the rate of change, or the average rate of change, is very similar to that. Okay, it just uses different notation. So it looks like change in y over the change in x, and you have f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. Guys, this f of x sub 2 and f of x sub 1 is just a fancy way to say y1 and y2. Okay, so average rate of change is the same idea as slope, but it's the slope of a curved line. And this first one says to find the rate of change on the interval from 5 to 20. Now remember, this doesn't specify it, but when an interval is stated, it's stated in terms of the x values. So this tells me that I want to know what is the slope or the tilt of this curve as I move from 5 to 20. That's my x1, x2. That's given in the problem. So I need to figure out what these points are. This one I'm doing graphically, so I'm looking for the points on the graph. So at 5, this ordered pair is 5, comma 10. So this is my x1 and then my f of x1, which is like saying y1. And then 20, I'm way up here at 40. So I have the ordered pair 20, 40. That's my x2 and my f of x2, which is like my y2. So I have the two ordered pairs, and I'm just going to plug and chug. Okay, don't overthink it. You're going to plug and chug. Okay, let me see if I can make some room here. So the formula for average rate of change is the change in y over the change in x. So we have f of x sub 2 minus f of x sub 1 over x2 minus x1. And I have those numbers based on my ordered pairs. It's a plug and chug. So I have 20, or not 20, excuse me, 40 minus 10 over 20 minus 5. It's a straight substitution. Okay, straight, flat out substitution. Don't overthink it. 40 minus 10 is 30. 20 minus 5 is 15. 30 divided by 15 is 2. So the average rate of change for this graph is 2. I have basically found the slope of the line that connects those 2 points. Question 20 asks you to find the average rate of change between 0 and 3. But instead of giving you the graph, they give you the function. So this is kind of like a 3-step problem. Okay, so we have to, first, we have to find f at 0. That's my x1. Then I have to find f at 3. That's my x2. That's given in the problem. And then we have to do the average rate of change. There's no other way to do it. You have to do those little intermediate steps. So let's see if I can maybe color code these for you. Okay, so if we do f at 0, f at 0 would be 0 cubed minus 0 squared minus 2 times 0 minus 4. So I would have 0 minus 0 minus 0 minus 4, which I hope you realize is negative 4. So if you think about it as an ordered pair, 0, negative 4, that gives you x1 and f of x1, which is the same thing as y1. Then I have to go back and I got to do f at 3. So if I do f at 3, I have 3 squared, or 3 cubed, excuse me, 3 cubed minus 3 squared minus 2 times 3 minus 4. Now again, if you need to, please get the calculator. 3 cubed is 27, minus 3 squared is 9, minus 2 times 3 is minus 6, minus 4. 27 minus 9 is 18, minus 6 minus 4. 18 minus 6 is 12, and 12 minus 4 is 8. So as an ordered pair, I have the ordered pair 3, 8. That gives me x2 and f of x2. I'm going to take both of those ordered pairs and substitute into the average rate of change, which is f of x2 minus f of x1 over x2 minus x1. So I have everything I need. It just becomes a substitution problem. So I have 8 minus a negative 4 over 3 minus 0. So I have 8 plus 4 over 3. 8 plus 4 is 12, and 12 divided by 3 is 4. So the average rate of change is 4. Okay, that is all of the answers for the review sheet for Module 2 or Unit 2, excuse me, the review for Test 2, which covers lessons 5 through 8.